Okay. Um, so in this stream, we will try to solve these three levels: binary search, counting sort, and divide and conquer. And after completing these three levels, we will be completing our sorting plateau section. Then we will have three more sections to go and one extra section. I don't know what the section will have, but things will be done, will seem to be done. I don't know, but we need to complete these as soon as possible so that we can have some confidence in us. I have completed two questions of binary search, two more to go. Like binary search has four questions. First and second questions were very easy. Okay, so we are on this question. The question name is sum of square numbers. Given a non-negative integer c, decide whether there are two integers a and b such that a square plus b square equal to c. Okay, so like I have thought something about this question. So we can do what we can do is um like mainly we have to like the maximum value of a and b can be uh like one can be 0 and another can be root c, right? So we will do and limit that will be equal to square root of c. Okay, and we will do while a is less than c, not c but limit less than equal to limit. Like only we have to figure the only thing we have to figure is um like if is b an integer or not, because a is an integer and we are defining int a equal to 0. Okay, so what we will do, we will find a target. Okay, in target, and that will be equal to c minus a square, a star a. Okay, so like this is b square, and we I don't know the STL syntax to find if it is integer or not, but we have a jugaad kind of thing that what we will do, we will um, we will make a variable int root target, and that will be equal to square root of target. Okay, and if target is equal to root target star root target, that means that root target is an integer, and like if it is a float then some values will be lost and this will not be equal. Okay, so we will return true, and if this doesn't come true anywhere then we will return false. This doesn't include the binary search right now, but let's see how it will play. The value of c can be up to 231. That's very it's a TLE. If target is less than 0, break. Okay, let's figure out what is causing a TLE. So we have c equal to 5, right? So what we will do, we will find the limit that will be 2. Okay, we will define int a equal to 0 and is so this condition is verified. So target will have the value 0 into 0 and c 5. Okay, and the target is not less than 0. So our target will be square root of this, that will be 2, and target is 5. So 2 into 2, and it is not equal to 5, we will not return true, and this will continue again. Okay, a is not getting added. A plus plus. Okay, so it's working now, and we have not used binary search to solve this question, but I think this will maybe put a constraint. I don't know. Let's see if we get the TLE or not. If we get the TLE, then we have to use binary search, but we will try binary search as well. Without it, we are not completing this question. Okay, quite a better result. People have used binary search, I think 50% people. Okay, so now we have to figure out how we can solve it using a binary search again. This was a brute force approach, and the only thing is that we have to find this, like between A to this, but how we will move the left and right pointer, that is a concern. But I think we can do it. Mm, We need to do that as well. Okay, let's start from here. Okay, we will first define the limit, that will be equal to, then we will define the A. But how does it how do we do this? Like, the integration of binary search is quite complex, I think, because like we are defining A and then finding the if the target is possible or not, right? So let's see the top solution, what they are doing. Okay, they have defined the two approaches, this two boundaries, then left this condition, define the sum. If sum is equal to this, return true. sum is less than, then left plus plus is sum is greater than right plus minus 1. Okay. We have to find the C, not A and B. We defined A and B and then move them. Okay, this is a fine approach. Better than ours, obviously. Hmm. It's fine. I don't think we have to solve this. Put it here. We should have solved the last question by our own, but okay. Let's move to the fourth question. I don't know why it is taking this much time to refresh. Okay. So the next question is search in a rotated sorted array. Okay, I think I have done this question. Yeah. On June 26, 2024. Okay. There is an integer array. Like the elements are moving to the right side, okay? So given the array nums after possible rotation, an integer target, return the index of the target if it is in nums or -1 if it is not. We have to use binary search for it. Okay. Mm, 4, 5, 6, 7, 0, 1, 2. Okay, let's see how did we do this question. Search in rotated. so like I figured something out about this question. Um, that okay, so like there will be a left pointer, there will be a right pointer, okay, and we will have a mid. So um, our target will be between mid to uh, mm, okay. Let's first try to write the um, this will be n minus one. And by so if the target is less than nums mid, what does that mean? If the mid is here and target is less than mid, okay. So like instead of only using the this condition, we have to also see if the target is greater than or less than the left pointer. Because let's use this example. We have the left pointer here and right pointer here, okay, and mid will be 0 1 2 3 4 7 7 divided by 3, so like 0 1 2 3 here, mid will be here, okay, and we have the target 0. So but we will see if the target is less than nums mid or not. So target is less than nums mid, so we will see if the target is less than the left pointer or not. If the left pointer is also uh, if the target is also less than left pointer, it means it's on the other side, okay. So like the smallest elements are pushed on the right side, right? So and target is less than um, nums left. This means we have to put the left pointer on the mid plus 1, okay. If target is equal to nums mid, we can just return mid, okay. And what if the target is like, if this condition follows, but instead of target less than this, target is greater than this, it means the target is at this half, okay. So we will return r equal to mid minus 1. But what if the target is greater than mid? This can be also possible. If the target is greater than mid, then what will we do? I think we need to do this. Target is greater than mid, okay. That means like for example here, mid is here and target is still. Can we do another example? But I think okay, target is greater than this and target is greater than mid, okay. Let's say mid is here and we have the target 7, okay. then the target is greater than mid. So the left will be on the mid plus 1. Target is greater than mid, left will be on mid plus 1, and target is also greater than this. And the target is greater than mid, but target is less than this. Target is greater than mid 7, but target is less than this. This cannot be possible, I think. How can this be possible? If the target is greater than nums mid, so the target will obviously, let's say the mid is here. So target is greater than mid. So the left will be right pointer will be let's return -1 if nothing is there. There will be a daily, I think. Yeah. I'm slightly confused about these things. I don't know why I don't put my whole brain into solving the question. Okay, so we have something as the name of our solution. Okay. We are at the mid. Okay. If the target is less than nums mid, that means here, okay, but also greater than this. Either I have. Okay. But if the target mid is here, if the target is greater than this, then the target is also greater than this. The target is greater than both of them. And length will be mid plus 1. And if the target is greater than nums mid, but less than this, this should work, bro. how to do this? Oh, mm, I remember that something like this will do the job, but I'm still not getting the pointers. There's something wrong here. I think I've written extra cases here. We don't require these much message. I just have to do a dry run. We'll do a proper dry run. Okay. And let's take 0 to 10 integers rotated by 3, like 10, 9, 8, 10. Okay. Then 0, 1, 2, 3, 4, 5, 6, 7. Okay. Then what we will do, we will find the mid. Mid will be on fifth index. Okay. Fifth index. Fifth index is 0, 1, 2, 3, 4, 5. Okay. So the mid is the nums mid, and the target is 10. Okay. So the target is greater than nums mid and also greater than this. If target is greater than both of them, the right will be on the mid minus 1. If target is greater than both of them, the right will be on the this. Okay. Let's say कि the target is 6. So left should be here. Okay. Okay. These are right. These are also right. ये तो हो जाना चाहिए, ये नहीं हुआ। Okay, these three questions we will do after. Like, we have these three questions and then the next stuff.